Introduction to functions. In this video, we'll define what a function is and also use the vocabulary domain and range, and we'll look at some examples of relationships that are and are not functions. We're mainly interested in functions of the real numbers, and those are usually given as equations, tables, or graphs. And function notation is a little tricky, so we'll talk about that too. The concept of a function is really important in mathematics, and a lot of calculus is framed in terms of functions. We say f is a function of a variable like x, and we write f of x like that. Now, what does that notation mean? Well, a function is a kind of relationship between the objects in two sets. The input set is usually called x and the output set is called y. And the function is the relationship. It's these arrows that connect things in x to things in y. Now, the rule of a function is that each x in the input set corresponds to exactly one y in the output set. It's okay for two inputs to correspond to the same output, but it's not okay for an input to correspond to two outputs. In math, we like to have exactly one answer for a problem. So a function is more like a vending machine than it is like a slot machine, because whenever I push B5 on the vending machine, I get the same bag of chips. But when I put money in and pull the handle on the slot machine, I get a different combination of symbols every time. There's three main ways we represent functions in math. A rule or an equation can represent a function. It tells what to do with the input variable. Or we can write a table where we have the input and the output. Or we can make a graph. So a rule or an equation might look like add 4 to the input number, and we would write that as f of x equals x plus 4. A table would have x for the input and f of x for the output. The input might be 0, 1, 2, 3, and the output then would be 4, 5, 6, 7. Every input corresponds to exactly one output. And a graph of this function, the same function in each case, would go through 0, 4 and have slope 1, so it's the line y equal x plus 4. But when we're considering it as a function, we can write y equals the function of x. The input sets and the output sets come from the real numbers. The input numbers are called the domain of the function. So if we look at this function, any real number can be an input for x, so the domain is all real numbers. In this instance of the table, we only have a few numbers, so the domain is just this set 0, 1, 2, 3. And for the graph, the domain is the x-axis. It's all the values of x that we can put into the equation to graph. The output of the function is called the range. The range is the answer set. When we put in an x, we get a y in the range. So here's the range of the table, and the range of the graph is on the y-axis. So let's practice finding out if something is a function or not. So I have two relationships here. The first one says at any time t, a car is some distance from home. Now, at each time t, there is a distance. The car could be 0 miles from home or 100 miles from home, but every time has a unique distance. But if my relationship is a given distance from home corresponds to a time t, that's not a function, because the relationship doesn't have a unique time for each distance. If the car sits in the garage all night, its distance is 0, but the time will be 1 hour, 2 hours, 3 hours. It'll have many answers in the time column. So the first one represents a function, the second one does not. Well, which one of these tables represents a function? For the first table, an input of 3 corresponds to an output of 2. An input of 4 corresponds to an output of 2. Each input is corresponding to an output of 2, but it's only got one arrow from it to the range. An input 3 doesn't correspond to another number as well as 2. So this is a function, yes, but this one where 2 corresponds to 3 and 2 corresponds to 4 and 2 corresponds to 5, 2 in the domain has 4 different answers in the range. That makes it not a function, no. If we look at a graph and try to tell whether it's a function or not, we need to check that each x in the x-axis corresponds to only one y on the y-axis. And we see that that's true on the left here. We can draw a line from any x up to the graph, but it never hits it more than once. On the other hand, on the right here, a line drawn from x will intersect the graph in 2 points, so this particular x right here has 2 different outputs in the range. That makes it not a function. This test of checking to see if an x has more than one output is called the vertical line test. If a vertical line goes through the graph at more than one point, it's not a function. So no over here and yes over here. So we've learned that a function is a kind of relation or correspondence between two sets, an input set and an output set, and the kind of relation that it is requires that each x in the input set corresponds to exactly one y in the output set. Now that means that 2 or more different x's from the domain can match the same y in the range, but the same x can't match more than one y. The notation is a little strange. It takes some getting used to. It doesn't mean a variable f times a variable x. It's read f of x, meaning that f is a function of x. And we sometimes use some other letters for functions like g of x or h of x. Usually x comes from the real numbers and the output, the range, is also in the real numbers.